Hello everyone, welcome to chapter 11 for CS 110 at Laurel Ridge Community College. My name is Amit Prambat and today we'll go over file systems and directories. In this chapter, we'll explore how operating systems organize, store, and retrieve data on secondary memory. We'll look at files, directories, access methods, and disk scheduling techniques. Understanding file systems is crucial because every program we use depends on the OS to efficiently manage large amounts of stored information. We'll examine what file systems, and directories are and why they matter. We'll distinguish between text files and binary files and learn how file extensions communicate the type and purpose of a file. We'll also define basic file operations such as opening, reading, writing, modifying, and closing files. These foundations help us understand how computers organize data. We compare sequential and direct file access methods and discuss issues related to file protection, especially in multi-user environments. We then explore directory trees and learn how to construct absolute and relative paths. Finally, we'll look at several disk scheduling algorithms which determine the order in which disk requests are handled to improve efficiency. There are three key terms here. A file is named collection of related data. The file system is the OS's logical view of all files it manages, and a directory is a named group of files. Together, these concepts form the structure that lets us store information persistently and retrieve it efficiently. Here, the slide talks about text files and binary files. A text file contains ASCII2 or Unicode characters such as .txt or .html files. A binary file contains data in a special encoded format such as images, programs, or audio files. Binary files are not meant to be read directly by humans. They require interpretation by software. Here we get a clarification on distinction between text and binary files is as somewhat misleading because all information is ultimately stored as binary digits. The difference lies in formatting. Text files use binary values interpreted as characters, while binary files use data arranged in specialized structures meaningful to specific applications. Here we discuss file types and extensions. The file types represent the kind of information stored, such as text, audio, or images. Most files include an extension like .doc, .jpg, or .mp3 to help the OS and the user identify correct program to open it. Extensions make file management predictable and intuitive. Here we identify common file types from examples. Chapter.doc is a document, figure1.jpg is an image, interview.wav and myfavorite.mp3 are audio files. Using the proper extension ensures that files open in the right software and that the OS can categorize and manage them appropriately. What kind of operations we might perform on files? Typical operations include creating, deleting, renaming, opening, reading, writing, appending, and closing the files. These actions enable programs and users to manipulate data stored on disk. Here we compare sequential and direct access. Sequential access reads data in order from beginning to the end, typical for logs or audio streams. Direct access allows jumping directly to specific logical records by number, ideal for databases where speeds and random access are important. Each method supports different storage needs. Here we see the visual demonstration of sequential access. To reach a record at the end of the file, the OS must read through each previous record. While slower for random access, sequential access is simple and efficient for linear data processing, like streaming media. We will see how direct access works. Files are conceptually divided into numbered records. By specifying the record number, the system jumps directly to the desired location. This makes tasks like searching or editing much faster compared to sequential access. Which access method is easier to implement? Sequential access is easier because data is read linearly, requiring minimal addressing. Direct access requires more complex bookkeeping to map record numbers to physical disk positions. File protection. Controlling who can use a file and how is important. In a multi-user system, protection prevents unauthorized access or modification. Examples include preventing one user from reading another's private documents or stopping accidental deletion of critical system files. Here we see Unix style permissions divided into three categories: owner, group, and others. Each category has permissions for reading, writing, or executing a file. This structure provides flexible control while ensuring system security. Directory trees. The slide reminds us that directory is simply a named group of files. Directories can contain other directories, forming a hierarchy, while the hierarchical structure helps organize large number of files in manageable way. Excuse me. Moving on. We introduce important directory related concepts here. Parent directory holds subdirectories. Subdirectories are contained within another folder. The directory tree is the hierarchical structure of all directories, and the root directory is the highest level folder in the system. Here is an illustration of Windows directory tree. It visually represents folders and their nested structure. Directory trees allow users to see file organizations at a glance and navigate the system intuitively. The working directory, the folder you are currently operating in. File actions like saving opening default to this location unless you specify a different path. Understanding the working directory helps and avoid confusion when managing files. The slide displays a unique directory tree. While visually different from Windows, the structure is similar, a hierarchical arrangement starting at root slash. Unix relies heavily on directory paths for navigation and system management. The slide introduces paths, text strings that show the location of a file. Absolute paths begin at the root directory and list all subdirectories. Relative paths begin from the working directory, making them shorter and often easier to use. Here the slide gives us examples. Absolute paths like C, program files, MS Office, winword.exe specify the full route from the root directory. Relative paths such as applications calstate.doc depend on your current working location. Understanding paths is essential for both navigating and scripting. Disk scheduling. As processes run, they generate disk access requests. Disk scheduling is the OS technique to use to decide which request to handle next. Efficient scheduling minimizes delays and improves overall system performance. The slide reminds us of seek time, the time required to move the disk head, and latency, the time waiting for the platter to rotate. Minimizing these delays is the goal of disk scheduling algorithms. This slide defines three scheduling algorithms. FCFS handles requests in arrival order. SSTF chooses the request closest to the current head position. And scan moves the head back and forth like an elevator, servicing requests along the way. Here we work through an example with cylinder requests. FCFS processes them in listed order. SSTF selects the nearest cylinder to the current head position of 26. These calculations help demonstrate efficiency differences between algorithms. Here the slide explains scan using the elevator analogy. The disk head moves from one extreme to other, servicing requests as it passes by. This reduces starvation and keeps head movement predictable. In the scan example, the disk head starts at cylinder 26 and moves towards cylinder 1. As it moves, it services requests in the order encountered. Scan ensures fairness by passing through all cylinders before reversing direction. Ethical issues or spam. Here, there are several questions about spam, how many messages we receive daily, why spam is expensive, whether we've spent spam, and what can spam act is. Spam is costly due to wasted storage, bandwidth, and time. The Can Spam Act establishes rules for commercial email and gives recipients the right to opt out. Who won the Turing Award in 1980 and for contributions to what area of computer science? The answer is CAR Hoare, honored for his fundamental contribution to algorithm design and programming languages, including quicksort and Hoare logic. There are several technology-related questions. RFID tags are radio frequency identification devices used for tracking objects. Some club patrons once accepted implanted RFID for access and novelty. HRV refers to heart rate variability, a stress indicator monitored by software. The eNeighbor system uses sensors to help track daily activities of elderly individuals for safety and early warning signs. All right, I hope you enjoyed this chapter. I'll see you in the next class. Take care. Thank you.